Crystals will grow into geometric shapes that reflect the arrangement of their atoms. Take galena, which has a cubic structure composed of lead and sulfur atoms. The relatively large lead atoms are arranged in a three-dimensional grid 90 degrees from one another, while the relatively small sulfur atoms fit neatly between them. As the crystal grows, locations like these attract sulfur atoms, while lead will tend to bond to these places. Eventually, they will complete the grid of bonded atoms. This means the 90-degree grid pattern of galena's crystalline structure is reflected in the visible shape of the crystal. Quartz, meanwhile, has a hexagonal crystalline structure. This means that on one plane, its atoms are arranged in hexagons. In 3 dimensions, these hexagons are composed of many interlocking pyramids made up of 1 silicon atom and 4 oxygen atoms. So the signature shape of a quartz crystal
that psychedelics could provide, to the extent that she thought that, if she could somehow capture the geometry she experienced in high fidelity, it could positively impact others who see them. She quickly gained an intuitive feeling that geometry was a result of the cognitive experience of psychedelics bleeding into the visual cortex of her brain, a visualization of her thoughts and experience. Unbeknownst to Josie at the time, scientists had already started to piece together that there was some truth to that idea, and in multiple ways. My hypothesis on the mechanism that creates psychedelic geometry is based in 2 different ideas. The first is related to the actual physical structure of the processes in our brains, and the second is essentially synesthesia. There is a long and fascinating story to the study of geometry as a result of the physical structure of neurons, which I would love to talk about, but which may not interest all of you. I have included some links to articles and studies in the description for those who are interested. Essentially, there is good reason to suspect that the patterns of neurons firing in our visual cortex essentially resembles some geometric shapes and patterns that can be seen on psychedelics. That these patterns, which are patterns that exist in nature outside of our eyes as well, called Turing patterns, are part of what allows us to see normally without visual noise under normal conditions. However, when the visual cortex is stimulated by things that are not normal visual stimulation, by gently pressing on the eyes, looking at strobing lights at certain frequencies, or by use of certain substances, we can actually basically see those patterns of firing neurons. However, the possible patterns and shapes directly caused by the paths of neurons firing is only part of the picture. Psychedelic geometry can be unfathomably complex in a way that these phosphine-type patterns are not, which brings me to the second part of my hypothesis. Classical or serotonergic psychedelics, things like LSD, psilocybin, DMT, and mescaline, cause the different parts of our brains to become more interconnected while we trip. There are many things we don't fully understand yet about psychedelics, but that is something that has been demonstrated and verified repeatedly, and studies are able to get increasingly specific on the forms that interconnectivity can take. For example, David Nutt, a researcher studying these topics, told Nature, quote, "We found that, under LSD as compared to placebo, disparate regions in the brain communicate with each other when they don't normally do so. In particular, the visual cortex increases its communication with other areas of the brain, which helps explain the vivid and complex hallucinations experienced under LSD, and the emotional flavor they can take. Synesthesia, as described before, is when one kind of stimulation is perceived as another kind of stimulation. It is understood to be caused by increased interconnectivity in different parts of the brain. To be clear, synesthesia is generally understood in a much more limited way than the experiences on psychedelics. Normally, even for people who do experience synesthesia in everyday life, the level of interconnectedness in the brain is nowhere approaching how intense it can be under the effects of psychedelics. I believe that this strong level of interconnectedness is essentially what allows experiences of psychedelic geometry to be so extreme, complex, and so immersive and connected to the rest of the cognitive experience of the trip. So, to put my hypothesis together, I think that some of the particular geometric forms that psychedelic geometry takes are caused by the shapes of neuron signals in the visual cortex. And I think that the rest of the presentation of geometry comes from interconnections in the brain, especially interconnections between the visual cortex and other parts of the brain, allowing essentially a visualization of things that are occurring in other parts of the brain. I propose that these 2 potential explanations work together, that the stimulation of the neurons firing in these patterns provides a structure for the signals coming from other parts of the brain to coalesce and merge into these incredibly profound visual experiences.